So topic materials, which is also a very important topic. We will find many questions from this topic. So the first one is a multiple choice question. The diagram shows a graph plotted using the results for an experiment in which a metal wire was stretched. The gradient of the graph equals to Young's modulus. So if the gradient of the graph is equals to Young's modulus, it means the graph is between the stress and strain. And the gradient is actually the quantity on the y-axis divided by quantity on x-axis. When the quantity on the y-axis divided by quantity on the x-axis, we'll get the gradient. So the Young's modulus itself is equals to Young's modulus divided by E, which is equals to stress divided by strain. So on y-axis we need stress, and on x-axis we need strain. So y-axis stress and x-axis strain, to me option D should be the right answer. Because why it's not force and extension or force, the reason is if this was the same question and they say gradient is equals to the spring constant or the stiffness, in that case stiffness is referred to K, the spring constant. So in that case the graph should be there between force on y-axis and extension on x-axis. But if the graph is there between stress and strain, the gradient will be equal to the Young's modulus. Is it clear, this question? Then the next question. The graph shows how the stress vary with the strain for a given material. And we have to label, like we have to define these terms, explain what is meant by each term: limit of proportionality, tensile strength, and the yield point. So you have to learn the standard definition for each of them. What is limit of proportionality? Basically, a limit of proportionality is a point up to which force and extension are directly proportional, or stress and strain directly proportional, or the object like the material or an object obeys the Hooke's law. So it is the point up to which the stress is proportional to strain, is refers to limit of proportionality. Now, what is the meaning of a tensile stress or tensile strength? Tensile strength means the greater, like the maximum stress which object can bear before it break or fracture. So the greatest stress before the object fracture, or the maximum stress at which the object fracture, is known as the tensile strength. And what about the yield point? Yield point means the point which a plastic deformation began, or for a small change in stress, there is a greater change in strain, or large increase in strain for a smaller increase in stress. So you can mention the point at which the object deformed plastically. So the plastic deformation occurs, that is known as the yield point. Using crosses, the letter shown above mark the limit of proportionality and the yield point. So where we should mark a limit of proportionality, you can use a screen annotation. Mark the proportionality limit on this graph. So, and we should label that as L, and then the yield point. So
is it yield point?
Yeah, yield point. Yield point is refers to for a small change in the force, there's a greater change in strain or small change in stress, greater change in strain. So you can identify, like this is the yield point region, like very small change in force and maximum change in a strain. So we can mark anywhere, like as you mark here, that is also correct. So this will be the yield point. And normally between the elastic limit and the yield point, we'll have between the yield point and the limit of proportionality, we'll have the elastic limit as well. Is it clear, this question?
Yes, sir.
In question 3, the top of a toy is pushed down and compressing the spring, and the suction cup adhere to the base and hold the toy down. So basically what happened, like there is a spring which is compressed. Compressed means we apply the force to reduce the side. A compressive stress is applied, and a toy is attached here, and the cup will hold this. Once we release the cup, the toy will move upward. After a short time, the suction curve leaves the base, causing a toy to jump. The compression force graph is obtained. Like this is the compression which is done. Compression means like decrease in length is refers to compression. So the maximum decrease in length is still 2, and after that it is not by applying a force, we're not able to compress much. Explain the shape of a section AB. So what is section AB? Section AB shows that because when we are increasing our force, compression is also increasing. It means in this region, the force, and it is a straight line which is passing through the origin. So we can mention that force is proportional to compression, or the material or the object is obeying a Hooke's law. So in this region, as it is a straight line passing through the origin, that force and compression are directly proportional. So force and compression are directly proportional in this region. And we can also say that the spring is obeying the Hooke's law. So force extension or force compression, both terms are there. Then explain why the section CD of a graph is horizontal. Like why there is no change in the length. Because what happened, like at this point, the spring is fully compressed, like it cannot be further compressed. That's why it is not changing the length, or the spacing between the coils, or there is no space between the coil. Like example, this was initial, but when we compress this, these coils will come so close to each other that there is no space left to further reduce the spacing between the coils. So why the section C and D is not changing the size. The reason is that what it shows that the spring is fully compressed. Like it cannot be further changed. Show that the stiffness of a spring is about 1000 Newton. So how we work out the stiffness? Stiffness is actually the value of the K, which is force divided by extension or force divided by compression. So, and whenever we solve, we will always take a linear region, a straight line. So I can take any force, like example, if I took 15 as a force or 10 as a force. So when force is 10, how much compression is there? We'll draw a line. This is about 0.9. But that is in centimeters, so don't forget to convert the units. So it will be 10 divided by 0.9, and we divide by 100, or I can say 0.9 into 10 power minus 2. So when we simplify, this is 10 divided by 0.9 exponent minus 2. What's the answer for this? Stiffness or K? 10 divided by 0.9 exponent minus 2.
It's having 1111.
So it is 1111. And in the question, they're saying we have to show it's about 1000. So 1111 Newton per meter is there, which is about 1000 Newton, because that's the question that we have to show that the stiffness is about. It's not like the same number, it's about that. Then in part C, as a suction cup is about to leave the base, the compression of a spring is 0.018 meter. Calculate the energy stored. So how much energy, because as a suction cup is about to leave the base, the compression of the spring, like this is how much the compression is there for a spring about. So what we can do, we can use half to get the energy. It is half force into extension or area under the graph. So 0.018 meter is there. So if we convert, because this is in centimeters, so it will be 1.8 centimeter as we multiply. So 1.8 centimeter is there, 1.5, 6, 7, and 8, because each box is 0.1, so this is 1.8. So we have to calculate the area under the graph for 1.8. So when it is 1.8, how much is the force? This is a force, which is 18. Or each box is 0.5, so it's 19 here. Each box is equals to 0.5. So what we will do, we'll take area under the graph, because area under the graph will give us the energy stored. So it will be half force into extension, compression. So it will be half the force applied is equals to it's 19 and multiplied by change in the length, that is from 0 to 1.8. The compression is, but because 1.8 is in centimeter, in meter we have to use, so that we'll get Newton meter, which is equals to joule. So 0.018 meter. So half 19 into 0.018. What's the answer for this?
0.17.
0.17 joules. So 0.17 joules of energy is stored by this spring. Is it clear?
Yes, sir. So can I use another formula like half kx square?
Yes, you can use that. You can also use that half kx square. You will get the same answer, because see, we work out the stiffness, so we work out the k. So if I use half kx square, I will get the same answer. It is half kx square. So it will be half, k was 1111 and x is 0.018. So when you simplify, how much is, what's the answer for this?
Zero 0.179.
So 0.179. So it does not make difference to the formula which you are using. 179 or 178 is there. But better, whenever a graph is given, use the graph to get the answer. Okay, instead of just directly using a formula. And in exam, when the graph is given to you and you're solving it, so always try to show you're working on the graph. Like example, if I'm finding the area under the graph, so I should highlight on the graph that I use this part, because some questions it's having marks to, if you're using your graph, you should mention, you should mark on your graph that what you're doing or how you're using your graph. So you should mark, you should shade that region. Then calculate the maximum possible height reached by the toy. So how we will work out the mass of the toy is 7.3 exponent minus 3 kilogram. So our assumption is all the elastic energy is converted into gravitational potential energy. That's our assumption. Practically, it won't be, but theoretically, when the we work out that 0.17 joules of the energy is stored in the spring, and there's a toy. So when it is released, the toy will move up. So it will have a gravitational potential energy of 0.17 joules. So our assumption is that all of the energy, like elastic strain energy, transferred to potential energy. So we want to calculate the height of potential energy is equals to elastic strain energy. Potential energy is mgh and elastic strain energy is 0.17. If we need the mass of the toy, that is 7.3 into 10 to the power minus 3. The gravity is 9.81. The height we don't know, and 0.17. So this whole factor is multiplied, other side will be divided. 0.17 divided by 7.3 exponent minus 3 and into 9.81. So which will be approximately 2.4 meters. And one assumption we made in our calculation, what we assume that there is no energy loss, or all of the elastic potential energy, elastic strain energy changes into gravitational potential energy, or there is no energy loss because of the air resistance or because of or left within the material or the spring, or no energy loss due to air resistance. And we can also say the elastic strain energy converted into kinetic first because it starts to move, and that all kinetic changes to gravitational potential energy. In question 4, a spring extended by 9 centimeter when a force of 6 Newton is applied. The limit of proportionality is not exceeded. Another identical spring is joined end to end, like with a spring, and the force of 4 Newton is applied. What is the extension of the pair? Like first, we attach a 6 Newton. So we attach a load of 6 Newton and increase in the size of this spring, that is 9 centimeter. Now what we did, we connect two identical springs end to end. Like this is spring 1, this is spring 2, and we connect them end to end and we attach a 4 Newton. Now we know force and extension are directly proportional. So if there is a force of if there is a force of 6, it was producing 9 centimeter extension. If there is a force of 4 Newton, how much extension will be there? X cross multiply. What is the extension for a spring, each spring? So it will be 4 multiplied by 9 divided by 6. So 9 multiplied by 4, that is 36, and 36 divided by 6, that's equal to 6. So X will be equal to 6. But so means each spring will extend or increase by 6 centimeter. Because this 4 Newton is experienced by spring 1 and this same 4 Newton is experienced by spring 2. So each spring will increase in length by 6 centimeter. So 6 centimeter for spring 1 and 6 centimeter for spring 2. So what is the total extension? What is the total increase? It will be 6 plus 6, that's equal to 12 centimeter. So 12 centimeter will be the total extension of this pair. Is it clear? Question?
Yes, sir.
Okay. Then the graph shows a stress and strain curve for 4 different samples. Example, if I say which object is brittle. Brittle means no or very small plastic deformation and an object can break, which is brittle material. So A will be brittle because no or very little plastic deformation. Which is stiff material? Stiff material means the material which need a greater amount of stress to produce a very small change in strain. or we check the initial slope. So which is a stiff material here?
Is it A?
No, if you check the initial slope, B is having a greater initial slope than A. Like this is a slope of B and this one is a slope of A. So B initial slope of B is more than A. So it means B is stiffer than A. Because stiffness refers to like it is difficult to stretch an object, difficult to deform an object, difficult to change the size of an object. That is the stiffness. So that's why it's not A, it will be B if the question was stiffness. And which material is malleable, easy, malleable, ductile? So in that case, D is malleable or ductile easily. So which material has a greater strength? Greater strength means which need a greater amount of force to break down. Like which material we need a greater amount of force or stress to break down.
A.
So it will be A. So strong material, A is the strongest material. The next is which has the greatest Young's modulus. Young's modulus or stiffness having the same meaning, that like the one which will have a initial slope greater will have a higher Young's modulus, or it will be a stiff material which is having the highest Young's modulus or initial slope. So that will be B. We will have a highest Young's modulus or initial slope. In question 7, a brochure states that a particular type of a wood is extremely tough and does not become brittle over a time. So it is what is meant by the term tough and a brittle. So we have to define what is the definition of a tough and what is the definition of brittle. What is the meaning of tough object? Like it can absorb greater amount of energy without breaking or cracking, or able to absorb lot of energy in the plastic region, or you can also mention able to absorb energy without breaking, or can show a considerable plastic deformation without breaking. What is the meaning of a term brittle? Brittle means that no or very little plastic deformation an object can break. So the brittle means that there is no or a little plastic deformation that will break down the object. So that is refers to a brittle material. A cricket bat is made of a wood, is found to have a dent after striking a cricket ball. Said type of behavior shown on the material of a cricket bat. So when the ball is striking the bat, the object deformed. And when, for example, if the when the ball strikes the bat and the bat changes its structure or a shape, what we call that it is showing a plastic deformation. Or plastic behavior that it deformed and does not return back to the same original position. If it was elastic, then it should return back to the same original position. A wood sample is clamped securely to a support beam. The light platform is suspended from a wood sample using another clamp. The dimension of the wood sample at X are known. The mass of 2 kilograms are added to the platform during the test process. The wood sample breaks at X when the total suspended mass is 84 kilograms. Show that the ultimate tensile strength is about 6 exponent 7 Pascal. So how we can show, like example, there's a wood sample. Say this is a sample of a wood. And it is fixed from the top according to the question. It is clamped from the top. And at the bottom, we have a platform. So there's a platform on which we can keep the load. So what we are doing, every time we are adding 2 kilograms. Like first we add 2 kilograms and we see whether it break or no. Then we add further 2 kilograms and then we check it break or no. Then further 2, and we continue this until the total weight which we added here is 84 kilograms. So when we add 84, this a sample of a wood will break down. So ultimate tensile strength means like the maximum stress which the object can bear before it breaks, which is also known as UTS. So how to work out the maximum stress? So sigma is equals to force per unit area. Means stress is force acting on unit area. What about the force? Mass is not the force, weight is the force. So mass is 84. What about the weight? Weight is mass multiplied by gravity, and weight will be the force here. So it will be 84 multiplied by 9.81.
824.
824. So the force is actually equal to weight. So that is equals to mass multiplied by 84 into 9.81, as you mentioned, that will be 824. Divided by area of cross section, that is 1.3, as I mentioned in the question. It is the area of the cross section is 1.3 exponent minus 5. So 1.3 exponent minus 5 is the area. So when we divide them, 4 divided by area, we'll get the maximum value of the stress which this object can bear. How much is this? What's the value? Which is about
6.3 10 exponent 7.
So 6.3 exponent 7. So 6.3 into 10 to the power 7. And the unit of the stress is, you can mention Newton per meter square or Pascal. Newton per meter square is equal to Pascal. So we just use the formula for stress and work out the final answer. The next, explain why this method of a testing may produce a large value of the a larger value than the true ultimate tensile strength. Look what they are saying in practical, like we work out the ultimate tensile strength, the maximum stress which can break this object is about 6.3 exponent 7. But we are saying this is an overestimated value. Like this may not be true. Practically, it may have ultimate tensile stress or ultimate tensile strength less than the value which we calculate. So what is the reason why our value is the overestimation? Because if you see, check in the question, every time we are adding 2 kilograms. Means 2 kilogram means every time how much the weight is added. So 2 multiplied by 9.81, which is equals to 19.6. So every time we are adding or increasing a load by force by 19.6. Like first when we place a load, it was 19.6. Then we add another load of 2 kilograms. That also increases 19.6. So maybe the object, like example, when we sum this, when we add them, the interval or the difference between the two values is 19.6. Like when first load is added, it is 19.6. Then the second load is added, it increases by 19.6. When third load is added, increases by 19.6. So every time the load or the force is increased by 9.6, but maybe the object might break within this. Like it's not necessary that every time 19.6 should increase. We should increase with a smaller mass or smaller weight so that we'll get the true value. But right now it will be an overestimation, that because we are adding the mass which is added is a 2 kilogram, which contribute to about like 19.6 Newton. So when we add, for example, we add 82 kilogram, then we add another load, then it will be 84 kilogram. So maybe 82.1 mass of 82.1 might break the object, mass of 82.2 might break the object, 82.3 might break the object, but we don't have that number. We have either 82 or 84, so means our value is not accurate, as we are missing the masses which should be there from 82 to 84. So the mass which are added in 2 kilogram, so which will maybe the object required between 82 and 84 to break the sample, like, or maybe the sample might break from a mass from between 82 to 84. Is it clear, this part? That why that our estimation is, like, our values may be overestimation. Explain why the sample of the explain why the wood sample used for this test is having this shape. What is the reason? Because we are finding ultimate tensile stress. So UTS. So the stress is equals to 4 divided by area. So when we have a small area, the stress will be higher. Like, it need a maximum value of the stress. Because if object is having a large area, then stress will be lower. So why it is having a shape like this? So when it is having a narrow center, the stress and area are inversely proportional. So it need a maximum force, or will get a larger value of the stress for a given force when it is having a small area. And the second thing, that should break at a right place or a particular place. Like, if what if the sample was a cylindrical or rectangular? So in that case, what happened when we are adding a load? Maybe the object, the sample might break from here, maybe break from here, maybe break from here. Many possibilities are there. But in this case, likely position where the sample will break is at the narrow, like the neck or the narrow part. So the advantage of using this shape rather than a rectangular or a cylindrical, so that it break at a specific point, and when we have a small area, so we'll have a very high stress, so we can work out or find the maximum stress which can break this object. The sample of the wood of a same type are not entirely uniform. What should be done to ensure that when carrying out this, like, we want to check the reliability of the results, how we can make sure that the results are reliable? So we will repeat the experiment, because whenever we identify the anomalies or random results, so we can remove them from our calculation. A physics book gives this definition: a material which show a large plastic deformation under compression. So two things are there. An object can deform under compression, like can be hammer, or object can be show a large deformation under tensile force, or can be drawn into wire or stretch into wire. So what we call, if an object deform under compression. So if the object deform under compression, we call that as a malleable, can be hammered into shape. So this object can deform under compression, and this object can deform under the tensile force. So if an object can, like hammer, deform under compression, we call that as a malleable. Can be hammered into shape. And ductile means can be drawn or stretched into wire. So ductile materials are used to make wire, and malleable materials are used to make sheet. So here it's option C, an object is a ductile material. In question 10, explain why the wire used when measuring a young modulus of a copper in a school lab is long and thin, and it's of 5 marks. The wire must be long and wire must be thin when we are determining the Young's modulus. So what is the Young's modulus? The Young's modulus itself is a stress divided by strain. And what is stress? Stress is force acting on unit area, and strain is change in length over original length. But when we simplify, it will be F L divided by delta L A. So means Y will have a longer wire and it should be thinner as well. So remember, stress is directly, what is a strain? Strain is change in length over original length. Or we can also say change in length is directly proportional to original length. Like if I have a, say, short wire, say 2-meter wire, when I apply a force of 10 Newton, it will show a smaller change in length. But same thing, if I have a 5-meter identical wire, but a length, like identical material, but the length is 5 meter, when I apply the same force, so it will show a greater change in the length. So longer wires will show a greater change in length compared to shorter wires. So that's why the wire must be long. And why the wire must be thin? What is the reason for that? For a wire to be thin? When it is having a small area, so there will be so we'll get a very large value of the stress. And if you check, the stress is equals to force divided by area. So if we have two types of wire, one is a thick wire, another one is a thin wire. Because when the wire is thin, we can easily apply the force, like small amount of the force can produce a change in length. But when the wire is thick, we need a greater amount of force to change the length. So what is the reason for thin wire? Thin wire will have a small area. So we'll get a large stress for a given force, or stress, because if the area is small, the stress will be higher. So we'll get a large stress, or we can also say that when it is thin, we don't need too much force to produce the extension. And the second thing, why the original length, like why the wire should be longer. So longer wire will show a greater change in length as compared to shorter wire. Is it clear? Question 10.
Yes, sir. But how did you multiply this F multiplied by L divided by delta L into A? How did you simplify this?
Look, Young's modulus is equals to stress divided by strain. Okay. And what is stress? Stress is force divided by area, and that is divided by strain, which is change in length over original length. When we change this division into multiplication, we make it inverse. So it will be L divided by delta L. So it will be equal to F L divided by A delta L. Like stress divided by strain. So this is stress, this is strain. When we change division to multiplication, we take an inverse, and then we simply multiply them. So it will be FL A delta L or delta LA.